So this question is a chi-squared goodness of fit. Okay, so we're told that if we keep reading down in the question, that it's a goodness of fit test. And it's a newspaper vendor trying to predict how many copies of a newspaper that they're going to sell. And it says that they're expecting, so they expect the same number of copies to be sold each day. Okay, so with any sort of chi-squared goodness of fit, there's always what we expect to happen. And that could either be, like this question, the same number each day, or it could be to fit a certain type of percentage or proportion that we expect, or it could actually be to follow a normal distribution or even binomial distribution that we've already worked out in the question. Okay, so in this one, it's that they expect the same number each day. So it's something to look for at the start of the question. And it tells us that the original and the null hypothesis, or the alternative and the null, are that it satisfies the model, which is the same every day, or it does not satisfy it being the same every day. So for the first part, we're wondering how many they expect it to sell each day. So to do that, it's saying in total, how many were there? And if I divided them equally into the 5, how many would that be per day? So it's essentially finding the mean. So I'm going to add together 74 plus 97 and so on. So 74 plus 97 plus 91 plus 86 plus 112. And I'm going to divide all of that by the 5 things that I've got. And that tells me that I'm expecting 92 each day. Now obviously that isn't exactly what we've got. So the point of a test, or goodness of fit test, is to decide how close are these numbers to 92. And therefore, is it just common that, it's not going to be exactly how we expect in theoretical probability? Or is it significantly like fluky data that we're suspicious of it? So to do this, we need to write down the degrees of freedom for the test, which is part B. So the degrees of freedom is the number of rows minus 1 times the number of columns minus 1. So it's got 1 row, the data, and we've got 1, 2, 3, 4. Okay, so the degrees of freedom would be 4. Okay, so it's basically just 1 less than the data you've been given. You've been given 5 days, so you want 4. And then part C is to work out whether or not you would take the null or the alternative hypothesis. So to do this, we're going to need to use our GDC to find the chi-squared value. So for goodness of fit, we're going to write down the expected data. Now the expected data is that it would be 92 every day. Okay, if you get that, just write a few more letters and then it will work. Okay, so 92 every single day. So all 5 days would be 92. And we also have the observed data. So this is what we have actually seen from our data that we've collected. And that's that Monday is 74, Tuesday is 97, Wednesday is 91, Thursday is 86, and Friday is 112. So that's what we've actually seen. So we're now going to do a chi-squared test on it. So it's menu, statistics, and then it's statistical tests. So stat tests. And we're doing a chi-squared goodness of fit. So goodness of fit there. And the observed list I called observed. And the expected list we called expected. We have to write in the degrees of freedom, which is 4. And the chi-squared value is 8.54. the p-value is 0.07. So if I just sketch this chi-squared test, we're told in the question that it's to a 5% significance level. So that's where this is 5%. And we're told that the critical value is 9.49. So this is the value that decides whether we take the alternative or the null. Okay, so the data that we got is that it's a chi-squared value of 8.54. So that's this side, 8.54. And the p-value is 7%, so it's actually a bigger area, so it's 7%. And therefore, it would be within the null hypothesis, so therefore we accept the null hypothesis. So your conclusion is that you accept H0 or the null hypothesis.